Hello everyone, welcome back to Learn DSA with Sakshi. I am Sakshi Liber and this is the final video of our DSA series. And today we are doing something special, a real world project to wrap up everything we have covered so far. So in this video, we are going to build a virtual file system in C, a mini operating system like environment where we can create, open, read, write, delete files on our own code, just like the Linux commands. But there is a question, why we are doing this? Because this project brings DSA to life. Throughout the series, we have covered all types of linked lists, like whether it could be singly, linked list, doubly, or circular in both C and C++, and then we move on to the stack and queues. Now, in this project, we'll use the linked list to manage nodes, just like the file tables in real operating system. Then we'll use array to maintain the descriptor table, UFDT array, and we will also use the structures and pointer to dynamically allocate it and manage files, and we'll write custom logic, our own algorithms to handle commands like the create, open, read, write, and more. So if you have followed this series till now, this is the perfect chance to see how data structures and algorithm are used in real system. Alright then, let's jump into the code and build our own file system in C. So here is our project, VFS, that is the virtual file system. So this is the flow of our this video. That firstly I'll introduce what VFS actually is. Then we'll see what its features, then commands, then file creation process, then writing, reading, then how to see the statistics of the file, and then at the end example workflow and conclusion. So this is how I will explain project to you. So before we jump into the code directly, let's quickly understand what a file system is. At its core, a file system is how an operating system organizes and store files. It provides a way to store, retrieve, and manage file on a disk. A file system also provides the necessary abstraction for interaction with files, like reading from and writing to them. In the context of our code, we are going to simulate some common operations that a file system performs, like creating file, then opening them, reading or writing to them, and even deleting them. So this is how we are going to implement a file system in our project. Now let's see the file system layout. Every file system is divided into four types, means every secondary storage is divided into four parts. So first part is the boot block, that is BB. Second is the SB, means super block. Then SB is followed by the disk inode, list block, that is we call DILB, and at the end the data block. So firstly we'll see what is boot block, super block actually it is, and then we are going to implement our project. So let's start with the boot block. A boot block is a block of size 1 KB which contains information which is close to the statistic. So let's start with the boot block. A boot block is a block of size 1 KB which contains information which is used to start means boot the operating system when we press power button on of the laptop. When we press the button, the code from the boot block gets executed, which is responsible to load the operating system from hard disks into RAM. In simple words, we can say that boot block means it is the code used to boot the operating system. So this is about the boot block. Now let's jump to the super block. Now super block is the block which contains whole information about the complete file system. The super block contains informations like the total number of inodes. Then what is inode? We'll see it later. Then list of free inodes, list of used inodes, total number of blocks, then total number of free blocks, and total number of used blocks. So this whole information will be stored in the super block. Then operating system is fetching the data from the super block for the file manipulation. So this block is very important. Now the next is the DILB, that is the disk inode list block. This block contains linked list of the inode. Here we are using linked list. So this is how it is connected to our previous lectures. So this block contains the linked list of the inode. Then inode. Inode is a structure which contains the information of the file. For every single file, a separate inode gets created. Don't worry, I'll present you a diagram so that you will get a better idea of how it is connected and in what way. So for the time being, let's understand inode. It's structure which contain every information of the file, and every file separate inodes get created. Now, then the last block is the data block. This data block holds the actual data of the file, and the data block is divided into multiple small blocks where size of the each block is 1 KB, that is the 1024 bytes. So this is about the data block. Now, inode is a structure created by the operating system, right? Which holds the information about the file like the inode number, then the block number of the file, where gets stored, size of the file, then file permission and file owner, etc. etc. When the user creates a file, the new inode gets allocated and the data that we write inside the file gets written inside the data block. Now, the way of arranging the information inside the hard disk is called the file system. So, this is what file system actually is. So, and the examples of file system is, let's say, NTFS means new technology file system, then FAT32, that is file allocation table, then UFS unique file system, etc. etc. Now let's quickly draw a diagram to get how our project is and the flow of our project. Without this, you don't get it very much. So let's draw with the diagram. Firstly, I'll draw it and then I'll explain to you. So this is the basic layout of the file subsystem, where this is the command prompt, our terminal, and these are the new area, that is the user file descriptor table, and in the U area, that is UFDT, that is user file descriptor table, that is the array, and then it points toward our file table. And from the file table, it's pointed to the in-core node table, and then it's get information from the DLB block. Basically, this is the four types of storage system, and it is divided into four types. That first is BB, boot block, second storage super block, then DLB, and then at the end data block. Now, I'll explain to you how the flow of the code will be. So, in this diagram, all the data structure of the file subsystem are created. When any program get executed, it considered as a process, right? So, for every process, the U area gets allocated, and inside the U area, one array is created, which is named as the UFDT. That is nothing but the user file descriptor table. And inside the UFDT, address of the file table gets stored. So, this is our file table, and its address gets stored in this UFDT array. Then file table is a table which holds the information of the file. File table consists of the four things. Here I created the four groups, and four things adds mode in which the file gets open. So first is the mode, then second is the offset of the file, and then the pointer of the IIT, that is the in-core inode table. The in-core inode table is the table where the actual information of the file gets stored. Then when we open the file from the inode, so inode from the DILB consists of various inodes. So inodes from the DILB gets loaded from DILB to in-core inode table, and the return value of open is FD, which contains the address of the file, and file table contains address of the in-core inode table, and IIT contains the actual inode, which contains the complete information of the file. So this is how the file system working is, from where it's get loaded and where it's open, where gets stored. So in this project, file gets created on the RAM virtually. So if you say where is the file created, so I'm not able to give you the output because it's get created on RAM virtually. So this is how about the project. Now let's begin with the code. So let's start with the CVFS. Here is the code of the CVFS. I prefer to show you the code directly rather than typing with you, because otherwise it will take a lot of time and then the video will be very lengthy and it will be very difficult for you to get all those things. So I'm trying to complete this project within this single video. Otherwise, you will not get to understand it properly and it will not link with you. So here is the full code. Don't worry, I'll give it to you. Now just understand what our project does and how is the flow of our project. So let's start the step-by-step explanation of the code. So just give your file name as the cbfs.cpp, and then here we include the files. These are the standard C libraries: stdioh for the printf, scanf, right? Then libvc, lib for using the malloc and free, etc. Then string.h for string operations like string compare, copy, and len. Then we also include the iostream library, and then we use, here are the macro definitions. So we define max inode 50. Then so define max inode 50 means maximum 50 files can exit at a time. So maximum length is 50 files. Then read and write. Here is the read and write. So used to identify the file mode, means one for the read and two for the write. Then we define the max file size. So it is 1024B is also okay, but I prefer 2048. So each file has a maximum size of 1 KB. And then here is the regular and special. It is the types of the file, like the regular text file versus others. So these are the regular and special. Then count, current, and end. So count, current, and end are used to move file pointer in the LC. Now what is LC? I'll explain to you. So don't worry about it. Now just understand. These are the micro definitions. Now let's move forward. So here is the structure, like the building blocks. So file structure is the actual file content, right? Now here we define one structure which contains total number of inodes and free inodes. And it has type def of superblock and pseudoblock. Then we use type def struct inode. This is for the superblock. Now this is for the inode. So inode contains inodes contain all types or all information about the files. So these are the information which inodes contain. Means it contains how will be the size of the file, then buffer, link count, then permissions 1, 2, or 3. One is for read, second is for write, and third is for both read and write. Then we create another structure for file table. So in the video, you saw what file table is. So it consists of the offset, that is write and read offset, then count, mode, and these are the pointer to pointers. Then we create one type depth structure for the UFDT, that is the array inside the U area, and it contains the file table and PTR file. Then so this is how the structures of the file table, file structure, then superblock, then global and variables. So just a summary for this code up till this. So a structure to define what a file is, then a structure is track file limits, and then global variables to store everything in memory. So this is all about the type structure. Now we have the void main function, that is, it is the manual function. So it will tell the user that if you want to create something, then this is the description and this is the usage, means you can how you can use these operations. In our project, we can create, then read, write, ls, then stat, abstract, truncate, open, close all, lseek, rm. So these are the many operation we can do in our project. So here is the description and how to use that operation. So this is the manual file. So it is just the description and usage of this. Then after the manual function, we have display function, display help. Let's say if a user want to open our project and understand what our project is. So if you want to, where if he means if he gets stuck, how to run the project, how the flow of our project is. So for this, and if we don't know the command, so these are the commands, and If once we write help, then it will all get displayed in our command prompt. So this is all about the display function. Then we have get fd from name function. So this function basically takes a file name as input and returns the file descriptor, that is fd, of that file if it is already open, and if it is not found, it returns -1. Let's say you have your UFDT array of 50 and that stored pointer to the open files. Then you loop through each index, that is from 0 to 49, and if there is a file open at that index, you will compare the file name with the given name, and if it is matched, then you return the index as FD, and if not matched, it will return as -1. So this is how we will get the FD from name. Then we have p inode get inode structure, means function. After getting the FD from the get FD from name function, we can access the inode. Like let's say we have p inode temp. Then p inode temp will be UFDT array of FD. Then it will from the file table PTR, and then PTR will point to the PTR inode. So what this actually means is, let's say UFDT array of FD. It means get the file descriptor entry. Then PTR file table means points to the file table. Then PTR inode points to the inode structure of that file, which has like metadata like the name, size, actual size, then the permission and count. So once we have pinode, we can access or update this metadata easily. So this is about the pinode, get inode. Then we have create DILB function. So this function is called only once. When the VFS starts, it creates a linked list of 50 inodes like the empty file slots. So this is how it function works. It only once means, and this code is just like our linked list code, right? And when it's get created, we print one message, that is DILB created successfully. Data inode list block is created successfully. And after that, we have, first of all, let's one more thing about the DLB is that each node is created using the malloc, and it is initialized to 0, then stored in the global linked list starting with the head, and each inode gets a unique number from 1 to 50. This is called the start of the main before any file operation. So this is how DILB works. Then we have initialize super block. Now, this initialize superblock function sets the starting value for your virtual file system. That is, total inode equal to 50 means maximum 50 files are allowed. Then free node inodes equal to 50 means all 50 are currently free. And then head equal to null means no file is created yet, so the file list is empty. We use this at the beginning to reset everything. So this is what I explain it, and this is what actually write in our code. So here while I is less than 50, so maximum 50 are allowed. And this is how it is linked with the count and permission function, offset and all. Then we have RM function. So this RM function is will remove the file. So how it remove, if we type our file name and then after that give some permission, and if it is correctly matched, then it will remove the file. Similarly, we can read the file, means what is actually in our file, what is the size of the file, it will all will get from this read function. So this is how the file function is. Then similarly we have the write function and the open file function also. Then we have the function of write close file, means we can close the file by name, just write the close and file name, then it will close file. Similarly, we can close all the files. If you don't want to open anything, just call this function. And then we have the LC and ls, means if there are no means if you, let's say, if you type one name and this file is not available, so it will get there are no files in your system. Then abstract, it will give the statistic of the files like file name, this is your file name. inode, this is your inode file size, like that. And if you give permission 1, it will read. If 2, write, and if 3, then read and write code. Similarly, this is like the statistic file. And then if you want to truncate a file from, let's say I want to truncate it from fifth size, so you can truncate it from fifth to end, or starting to that specific position. So this is all about the functions, that is create, write, read, truncate, statistic, close, remove, exit. So this all function we write here. Now here is the main part of our program. So this is the main interaction loop of your virtual file system. It simulates how the user interact with the system. So this is the main loop, and then execute them by command. So commands you can use are the create to create a file, read to read data from the file, then write to write data to the file, close to close a file, stat to get information about the file, and abstract to get information about the file using the file descriptor. Then we have exit to exit the system, and close open all files. Then the program keeps running in a loop until the user type exits. So in this way, so this is what we write. If you want to truncate, then you have to do like this. If you want to create, then open, read, then else. So this is how we call each function, and the program keeps running until user types the exit. So let's take one example. So this is the whole code of the CVFS project, and it is of the around 800 lines. So I know this sound a bit complex, but trust me, with some hands-on practice, it will make more sense. And the key is to keep trying this concept in your code, and soon you will be working with the file systems like a pro. So don't scared if you don't get in the first go. You will definitely get it when you try it one or many times. Now let's see the output of the code, how to give commands in the command prompt. So for this, just open your command prompt. So opening with your command prompt, go to your folder, then type G++ as our extension is CPP. So G++, then our file name, that is cvfs.cpp, then -o my.exe. Then press enter. Then just write my.exe. So say it gives a message as DILB is created successfully, and it is the cursor is stop here. Now how to give commands? How is the flow? Don't worry, I'll explain to you. Now first type help here. Means let's say I'm a user and I don't know anything about this. So when I press enter, these are the commands that to use in the project. So after pressing help, then we can create one file. So for creating the file, we have to use create. Then type man for create. Mean I want a manual for create. So how to use the create functions, create and then file name. So this is the manual. So just write create, and let's say our file name is the demo one, or let's say demo.txt simple. Then press enter. As it said, no command found, because in our code we give that create, then name of the file, and after that give the permission. So I just want to read and, let's say, read and write both. So 3. So file is successfully created with the file descriptor. Now how to see the information of this file? So how to see it? For this we are using stat function. So stat, then your file name, that is demo.txt. Then this is the statistical information of our file. That is file name is demo.txt, inode number is 1, then file size is 2048 dp. We initialize it in our code in the starting part. Then actual size is 0 because it is the empty file. So actual size is 0 and reference count is 1. and we have gave it a permission 3, that is the read and write both. Then after that, let's say I want to list all the file, then just ls, then it says file name, then inode number, size and link count, it will give to us. Now I want to write in the file, so for that type write, then our file name, that is demo.txt, and press enter. Now the data, what you want to enter your file. So let's say I want to enter hello world. Now the it's get written in your file. Now I want to see what I write and what is the size of my file now. So for that, demo.stat, demo.txt again. Now let's see, file name is this, inode number is this, and see the actual size is 11, whereas here is the 0, and now it is updated to 11. So this is how we can write in our file. As I write the content in the file, let now the actual size of the file is 11, and here is the anything. So this is how the size gets updated when we write something in your file. Now I want to, let's say, read the file. So for that, read, then demo.txt, and let's say I want to read the first two letters, so I am giving 2. Now it is giving our data is the hello word and first two are the he. So in this way we can read the specific letters from our file. So this is how we can read it. And then now I want to close the file, so for that, close. In the same way, you can close the file, then remove file also. And if you want to exit from this, then just simply type exit and enter, then terminating the VFS system. So in this way, you can give the commands to run your project. So our project covers the basic commands to create, read, write, and manage files in our virtual file system. So in this way, we completed our the customized virtual file system project also by using the linked list and arrays. And that's it. We have just completed our VFS project. I hope you found this video helpful and that it helped to you connect all the dots from the previous topics we have covered. Remember, mastering DSA is not just about memorizing concepts, but also about applying them in real world projects like the one we just completed. With everything we have learned, you are now equipped to tackle even more complex problems. So that's all about the DSA series and the CVFS project. And that's a wrap up on our Learn DSA with Sakshi series. We have covered everything from linked list to stack and queues and even build a VFS project in C. I hope you found all this concept helpful and that you are now confident to tackle any DSA challenge that comes your way. It's been an amazing journey, and I'm so grateful for all of you who have been following along. But don't worry, this is just the beginning. Stay tuned for more project and advanced topic in the future. And thank you so much for being a part of this series. If you found this helpful, make sure to like, subscribe, and hit the bell icon so you never miss a new video. Drop your thoughts and questions in the comment. I would love to hear from you. Until next time, keep coding and keep learning. So, this is Sakshi Labor signing off from this series. Thank you.